materials that you'll need to make a solar-powered cell phone charger are a cell phone charging cord, 4 AA batteries that are rechargeable, a AA battery holder, a solar cell, a diode, a soldering iron, lead solder for the soldering iron, and wire strippers. This is the cell phone and the cell phone charger that I'll be using for this project. As you can see, I already cut off one end on the cell phone charger and have stripped back the insulation so I can get to the 2 wires that I will be connecting to the solar cell. This is the solar cell that I'll be using. It is from a solar light that you put in your garden. I've already disconnected the wires that connected to the battery right here and will now be connected to my battery pack and to my cell phone. The red wire is the positive wire, is the negative. This is the battery pack and batteries that I will be using. These batteries are rechargeable, so they can be charged by the solar cell. These 2 wires will be connecting from the battery pack to the solar cell and to the cell phone. The battery pack will be collecting the power from the solar cell when the cell phone is not connected to it to help charge the cell phone quicker and more efficiently. This is the diode that I will be using. A diode makes sure that electricity runs only in one direction. The diode will be faced in this direction going that way, allowing electricity to flow from my solar cell to the battery pack and to the cell phone. The tools you'll need for this project are a soldering iron and lead solder to connect the wires together and solder the joints. You also need wire strippers to strip the insulation from the wires so you can get down to the copper to solder the joints. Here's a diagram of what I'll be doing in this project. As you can see, I have the solar cell with the 2 wires coming out of the bottom. The positive one will be connecting to the diode, which is faced in a direction that allows electricity to flow from the solar cell to the battery pack and to the cell phone. I will then connect the negative wire from the solar cell also to the battery pack and to the cell phone. Now I will be connecting the diode in this direction from the solar cell. The next step is to connect the diode to the battery pack, and I'll be using this wire. Next, I want to connect the positive wire from the cell phone charger to the positive from the solar cell and the battery pack. The next step is to connect the phone charger's positive wire to the positive wire coming from the solar cell and the battery pack. Now I need to connect the negative wire from the solar cell from this wire to the battery pack and the negative wire in the battery pack. Final step of the project is to connect the negative wire from the cell phone charger to the negative from the solar cell to the battery pack. To show you that my solar cell is producing power, I've hooked up a voltmeter. As you can see, right now it's producing about 0.47 volts. This is under a shop light. When I put a halogen light, you can see it jumps to almost 2 volts. This would be powering the batteries, and then you would hook up your cell phone to charge. As you can see, when I hook up the cell phone, it is ready to charge. The next step is to figure out how much energy I am saving by using the solar-powered cell phone charger. So I have completely ran out the battery life on the cell phone, so I will now plug it into the outlet to find out how many hours it takes for it to charge, and then I will be able to convert that and figure out how much energy I'm saving. For my calculations to figure out how much energy I am saving by using the solar panel to charge my cell phone instead of an outlet, you have to look at the charging cord for the cell phone. My cell phone charging cord puts out 5 volts or 700 milliamps of energy. It took my cell phone 65 minutes to charge fully. I found an equation to figure out my consumption of kilowatts, and it's watts times hours used per day divided by 1,000 will get you your daily kilowatt consumption. Since the equation calls for watts, I have to convert my 700 milliamps to amps, which I do by dividing the 700 by 1,000. I then multiply that times the 5 volts, which equals 3.5 watts. Now I plug that into my equation, so it's 3.5 watts times the 1.167, which is my hours that it took to charge my cell phone. Divide that by 1,000, which equals my 0.0048 kilowatts, and that is my daily consumption. I then multiply that times 365 days in a year, which usually you charge your cell phone almost once a day. So that equals 1.49 kilowatts, and that is how many kilowatts I save a year by charging my cell phone using a solar panel instead of using an outlet.